The next shape we're going to talk about the area of is a trapezoid. And we're going to start this out the same way that we did yesterday with our triangle. We're going to see how a trapezoid, if we do a rotation, will resemble some of those shapes that we've seen before. Okay, so up here it says that they want us to take this trapezoid and they want us to do what we did yesterday, rotate them about a point. G is this midpoint that they've put on one of the non-base sides. Okay, now remember, patty paper would help with this, so if you still have something like that from the past. However, yesterday we didn't do anything with patty paper, we just did the rotation. So I'm going to go ahead and just show you what it looks like up here as well. But also, before we begin with that, I want you to just take a look at these trapezoids. So remember trapezoid, when we talked about the quadrilaterals back in first semester, trapezoids were kind of their own unique shape. Like when we went over the quadrilaterals, we talked about how parallelograms, rectangles, a rhombus, and a square, like all of those were very closely related to each other. They kind of all had some same properties. They behaved a little bit like each other. They were kind of like in a family of shapes, if you will. And the trapezoid was kind of the one that was separate. Like we had a totally different way to think about trapezoids. Trapezoids had their own set of properties. And so when we look at the trapezoids here, we're seeing some of that same stuff where we've got these bases. So notice how there's like a B1 and a B2. So those would be representing your two bases. And then there's a height. Now, just like before, we always want to use a straight up and down side for our height, or it has to be on the inside or on the outside of a trapezoid. So even on the second one, they have this height on the inside, but it could be out here. That would be the height too. Or you could even have the height here. That would be a height as well. Okay, so they can kind of draw those in a lot of different locations. But when we talked about like triangles, and when we talked about parallelograms and rectangles, they only had one base. Trapezoids have two bases, and they're those parallel sides to each other. So usually they're the top and the bottom of a shape when we're dealing with the trapezoid, but sometimes if the trapezoid's on its side, those parallel sides might be on the left and the right-hand side. But so that's going to be like one key difference that we have here with our trapezoids. Okay, so I'm going to go ahead and do my rotation. I'm going to take this trapezoid on the left and I'm going to rotate it around point G. And I'm going to do the same thing over here on this side. And so when I do that on the left one, it's going to look like this. Okay, and when I do that over here on this other side, let me fix that one. It's going to look like this. Okay, so if you look at these two trapezoids that I now combined together, what shape did I create on the right-hand side? I'm sorry, on the left-hand side. Yeah, this one's a rectangle. And what did we have on the other side? Yeah, a parallelogram. Okay, so now that we've seen that we're kind of making these rectangles and parallelograms just like we did with our triangle yesterday, what I want us to do now is figure out what would our dimensions of this new polygon be. So what would be the dimensions of our rectangle and what would be the dimensions of our parallelogram, okay? Now we're still thinking about our bases here. So remember for the trapezoid that there was base 1 and base 2, okay? Now when I rotated it around and you're thinking about the dimensions of your rectangle, like all the way across the top, count the number of squares that it is from here all the way to here. How many squares do you get? You get 9 total, right? Okay, now let's talk about where those came from. This part of it, from this dot to this dot, was from the original trapezoid on the bottom. So that was like my original base 2. And then from here to here, that came from my base 1, because when I rotated it, I added that on to the bottom, okay? So down here where it says base, I'm going to write this out as base 1 plus base 2 is equal to 9. That's how I got that whole distance across there. Okay, now my height didn't really change because I didn't add or subtract anything from that. So how tall is this shape? Yeah, it's just 3, okay? So let's do the same thing over here on the parallelogram. Again, think about your bases because when I rotated it, I'm moving one of those bases to another area. So you can think of it as across the top or you can think of it as across the bottom, but that's still going to be base 1 plus base 2 to get your whole dimension here. So how far is it from here all the way across to there? Oh, I went too far. 10? Okay, so base 1 plus base 2 would be 10. And you can check that, like base 1 is 1, 2, 3 squares. And so down here it should be 7. So 1, 2, 3, 4, 5, 6, 7 squares. But when I added them together, I got that 10. Okay, now what's the height of this one? And be careful because it is a parallelogram, so make sure you're thinking correctly of the height. Yeah, it'd be 2 squares. Okay, so your height is 2 for this one. So now that we have like our full base and we have our full height, what would we do to find the area? What would we do with those numbers? We would multiply them, remember, because the area of a rectangle and the area of a parallelogram is base times height. So for my rectangle here, I'm going to take 9 times 3, which would be what? 27. And then what about over here on the parallelogram? It would be 10 times 2, which is 20. Okay, and again, these would both be units squared. Okay, but now let's think about this in terms of that original trapezoid. So like we did yesterday with our triangle, remember we talked about how the triangle, when you flip it over, when you did your rotation, that it doubled, basically. We took that triangle, we doubled it to get our new shape. We're doing the same thing here with our trapezoid. So you can still think about how you doubled the trapezoid, but if you wanted to go back to just the single trapezoid, what would you need to do for your area? Yeah, you'd have to divide it by 2, right? Cut it in half. So I'm just going to write we'd have to divide by 2. And that would be true for the parallelogram example and for the rectangle example again. So let's think about how we would write this out as a formula. We can't just say for a trapezoid, base times height divided by 2, because how many bases were there on my trapezoid? There was 2 of them, right? And what were we doing with them up here when they wanted us to write out our base length? We were adding them. So when we think about that in our formula, we have to have that be reflected. So the area of my trapezoid formula is going to look like this. We're going to take our base 1 plus our base 2. We're going to take that times the height, and then we're going to cut it in half. So we're going to divide it all by 2. And again, a couple of key things. Your base and height still need to be perpendicular. So you still need to have a 90-degree angle showing there. And another thing to just note is that the base 1 and base 2 should be parallel. And that's always kind of a way that you can determine what are the bases. Because again, on your trapezoid, you're going to have 4 sides. You want to be able to identify your bases. So look for those parallel sides. And then you then want to be able to find your height. And your height needs to be perpendicular, create a 90-degree angle with your bases there. So like on the first one up here, the height was built into the shape because that side was already standing upright. Over on this one where we made the parallelogram, my height was, they drew it on the inside, but I also had talked to you guys about how it could be on the outside of the shape too. Okay, so let's do some examples here at the bottom of our page where we actually find area. So be able to identify all those pieces. Be able to tell me what's base 1, what's base 2, what's my height. Okay, so let's just go ahead and list those things out. What would you guys say is your base 1 and your base 2? Just the 5 and the 22, okay? And then what's our height? The 4, okay? This is kind of one of those, it's pretty cut and dry. They're not making you think too hard or find anything. So let's go ahead and plug this information into our formula. So we're going to do 5 plus 22. Those are my bases. We're always going to add those. Take it times my height, which is 4, and then you're going to cut it in half. So you're going to divide by 2. Now, if you wanted to, you could do some simplifying before you do the math. Okay, you could maybe take that 2 into the 4. You don't have to do that. You can just do this as it's written. Okay, but this is going to come out to be what? $54. And what's your label for area still? Centimeters squared. Good. Okay, not too bad. Like I said, that one's pretty easy because they're giving you everything that you need. All right, now let's take a look at the next one. Again, I'm going to start out the same way. I need to know what's my base 1, what's my base 2, what's my height. Okay, so let's think about this on our picture a little bit. We're missing some sides that we might need here. If you look at like the top and the bottom, they both have the dash through it. So what does that mean as far as their measurement goes? Yeah, they're both 8 because this side over here is 8 and it also has that dash through it. So these all have the single dash, which means they're all congruent. So we're going to say this is 8 centimeters as well, and this is 8 centimeters. Now, just to clarify, this 14 is talking from here to here. Okay, so they're not saying that the 14 is all the way across. Notice how they kind of like shifted it off to the right there. So they're trying to tell you that like just the bottom portion of like that triangle piece is 14. Okay, so what would be your basis for this one? The top one is 8, right? So this one is one of our bases. And then the bottom one is how much? Good, 22, because you have to add the 8 and the 14 because those combined are going to give you your bottom base. Good. Now, what's your height? It is this 8 out here. Now, they drew in that dotted line there, but remember, this isn't getting any bigger or smaller, so this is still 8 in here too. So that's still our height. All right, so now let's plug this into our formula. So we're going to do 8 plus 22. Take that times our height of 8. Okay, we got a lot of 8s in this problem. And then we're going to divide it all by 2. So go ahead and take a minute to calculate that and tell me what you get for your area. What did you get? Okay, label. Good, 120 centimeters squared. Very good. Okay, any questions so far? All right, last one. Okay, let's start out the same way. I need to know what's base 1, what's base 2, what's my height. Do you know any of those things just by looking at the picture as it is right now? Okay, you know one of the bases is 8 because that's across the top. Good. And the height is 5. Okay, so we can go ahead and put that there. Remember, this 5 would also be here on your triangle or on your trapezoid. Now, how long is the bottom base? Or, you know, there's no number there. So how would you maybe start reasoning your way through that? So you know from here to here is how much? It's 8, right? Because that's from the top. So that would be the same amount that you can just transfer down. But how would I figure out how much it is from here to the other side of the trapezoid? What did you say? Yeah, 5, 12, 13, right? This is one of those cases again. Let me put that 12 in the middle here. It's one of those triangles that we've talked about, and I've said to you guys it's going to show up a lot, right? So 5, 12, 13 is that Pythagorean triple that we've talked about. So that allows you to fill in that bottom side there, that bottom half of the triangle. So now how long is that total base on the bottom? Good, it's 20. So now let's plug this into our formula. So what's that going to look like? Good. 8 plus 20 times 5, all over 2. So go ahead and take a minute to do that and tell me what you get. Good. You get 70 centimeters. All right. Squared. Good. Any questions about trapezoids? Okay, so that's going to do it for that. We're going to have a worksheet now that goes over trapezoids. And you're going to see problems similar to what you saw with triangles yesterday. You're going to have to draw in the height on your trapezoids, and then you're going to be finding area. And sometimes they're also going to ask for perimeter. So make sure when you're doing perimeter that you're adding up all the sides. And you still might have to do some Pythagorean theorem. You might see some of those triples that we've talked about before. Okay, or there might be some new ones maybe that start to show up on this assignment too.